Hello, in this video we are going to learn how to solve radical equations. So we're just going to dive right into examples. In this example we have this 2 times the square root of x minus 1 equals 8. The first thing that we need to do every single time is to isolate our radical. Okay, so to achieve this, in this case we have a 2 out front, 2 times the radical. So we need to divide both sides by 2. And so now we have the square root of x minus 1 equals 4. Now the inverse of square rooting something is to square it. So we're going to square both sides because our rules for equations still apply. What we do to one side we must do to the other. So squared cancels out our square root. So we have x minus 1 equals 16. And to finish solving out this equation we add 1 to both sides, and so we get x equals 17. Now here is the important thing, is every single time we solve these, we need to check for extraneous solutions. Extraneous solutions is something that we get when we solve, but does not actually make the equation true. So 2 times 17 minus 1 equals 4. We're asking, does this equal 4? So 2 times the square root of 16. The square root of 16 is 4. 2 times, this is supposed to equal 8. So 2 times 4, and 2 times 4 is 8. So this does equal 8. Therefore, our solution is indeed x minus 1. So let's do another example that's a little bit more complex. This equation is the square root of 27 minus 3x plus 3. So once again, we need to isolate our radical. And to do that, this time we need to subtract 3 from both sides. So now our equation is going to say the square root of 27 minus 3x equals x minus 3. This time we are still needing to square both sides, but now we have a binomial on our right-hand side. This tells us that we need to do x minus 3 times x minus 3. That's x times x is x squared. X times negative 3 is negative 3x. Negative 3 times x is negative 3x. And negative 3 times negative 3 is a positive 9. So x squared minus 6x plus 9. Be sure to do this step right here. Do not say x squared plus 9 or x squared minus 9. That is incorrect. So now we have 27 minus 3x equals x squared minus 6x plus 9. So this is a quadratic equation because we see the squared. So that means that we need to set this equal to 0. So I can subtract 27 from both sides, and I can add 3x to both sides. So now we have 0 equals x squared minus 3x minus 18. And what factors of 18 subtract to give us negative 3? We have 1 and 18, 2 and 9, 3 and 6. So 3 minus 6 equals a negative 3. So these are our two factors we're going to use. Putting them both over ax, we know that we have 0 equals x plus 3 and x minus 6, x minus 6. And x plus 3 equals 0, so x equals negative 3. And x minus 6 equals 0, so x equals 6. Now, we still need to check. So we have to do the square root of 27 minus 3 times negative 3 plus 3, and we're asking, does this equal negative 3? So negative 3 times negative 3 is 9. 27 plus 9 is 36. The square root of 36 is 6. And 6 plus 3 equals 9. It does not equal 3. So now we know that negative 3 is an extraneous solution. We still need to check 6. So the square root of 27 minus 3 times 6 plus 3, does that equal 6? 27 minus 18 is 9. And the square root of 9 is 3. And 3 plus 3, does that equal 6? Yes, it does. So we know that our only solution is x equals 6. Let's do another example. In this example, we have all kinds of stuff outside of the radical. So we still need to isolate our radical. And to do that, our first step, this one's a little bit different, our first step is to subtract x. Because we can't, this 2 is multiplying, so we can't divide by 2 first. So now we have 2 square root of x minus 3 equals 6 minus x. I was trying to put x and 6 in the same word. I know that 2 is multiplying my radical, so I need to divide both sides by 2. So now I have the square root of x minus 3 equals 3 minus x over 2, or 1/2 x, whichever one you want. I'm going to do 1/2 x. And then we need to square both sides because we do indeed have our radical isolated. See, there's nothing else over here on this side with the radical. So let's go ahead and let's FOIL out this binomial. 3 minus 1/2 x times 3 minus 1/2 x. And so now we have 3 times 3 is 9 minus 3/2 x minus 3/2 x plus 1/4 x squared. It's not very pretty, but it's okay. 9 minus negative 3 minus 3 is negative 6 over 2x plus 1/4 x squared. And we know 6 over 2 to be the same thing as 3. So 9 minus 3x plus 1/4 x squared. So we have x minus 3 equals 1/4 x squared minus 3x plus 9. I wrote this out in standard form now, but I kept each sign with the appropriate term. I once again see a squared, so that means I need to solve for 0. So I can do that by subtracting x from both sides and by adding 3 to both sides. So now I have 0 equals 1/4 x squared minus 4x plus 12. Now to factor this, to get rid of this 1/4, because that 1/4 is pretty gross, especially when it comes to factoring. To achieve this, I can multiply the entire equation by 4. So now I'm going to get 0 equals x squared minus 16x plus 48. We need factors of 48 that add to give us a negative 16. So 48 we know to be 1 and 48, 2 and 24, 4 and 12, bam, bam, right there, that equals 16. But we need it to be a negative 16, right? So we need negative 4 and negative 12. So we have x minus 4, x minus 12. Setting both of these equal to 0 because I ran out of room. I'm writing over here on the left-hand side, even though that's so gross. X equals 4 and x equals 12. But remember, when these are radicals, I need to check for extraneous solutions. So to do that, I need to plug my x values into the original equation. 4 plus 2 times the square root of 4 minus 3, does that equal 6? This simplifies to 1, and the square root of 1 is 1. So 4 plus 2, does that equal 6? Yes, it does. So we do know that right now we at least have x equals 4, but we also need to check x equals 12. So 12 plus 2 times the square root of 12 minus 3, does that equal 6? So 12 minus 3 is the same thing as 9, and the square root of 9 is 3. So 12 plus 2 times 3, that's 12 plus 6. Does that equal 6? No, that equals 18. So we know that 12 is not a solution. Only 4 is. Let's do one more example where our radical is not of the squared nature. In this example, we actually have a radical of the cubic nature. We see that it's 1/3. And we know that this is the same thing as writing 3 times the cube root of x minus 2, because we learned that at the beginning of this unit. So let's go ahead and start solving this. Same rules apply. We still need to isolate this radical right here. And to do that, I'm going to divide both sides by 3. So I have x minus 2 to the 1/3 power equals 4. Now I see that I have my radical isolated. Even though it's written in a different form, it's still a radical. So this time, instead of squaring both sides, I need to raise both sides to the 3rd power, because that is what matches this radical right here. So now I'm left with x minus 2 equals 4 times 4 is 16, and 16 times 4 is 64. 4 cubed is 64. So to solve this, I'm going to add 2 to both sides, and so x equals 66. Let's check this, okay? 3 times 66 minus 2 to the 1/3, does that equal 12? 66 minus 2 is 64. You can put the cube root of 64 in your calculator if you don't know that it's 4. And does 3 times 4, does that equal 12? Yes, it does. So now we have verified that x equals 66 is indeed our solution to this equation. So that concludes our video for solving radical equations. Some high points are to make sure that you isolate the variable and to always check for an extraneous solution.